Question 29. The diagram shows the graph of y equals c ln x, where c is greater than 0. Part A. Show that the equation of the tangent to y equals c ln x at x equals p, where p is greater than 0, is y equals c over p multiplied by x minus c plus c ln p. The gradient of the tangent at any point on the curve is given by the first derivative dy dx. Given y equals c ln x, dy dx is equal to c over x. At x equals p, the first derivative is equal to c over p, and also the y-coordinate when x equals p is c multiplied by ln p. And we get that by substituting x equals p into the equation of the curve. Now what this is saying is that the tangent passes through the point p, c ln p, and that'll be useful a little bit later on. Now the equation of the tangent is in the form y equals mx plus c, or y equals mx plus c1 here, because this c is different to this c here. So this c here, I've called it c1, refers to the y-intercept of the tangent. Now the gradient m is c over p, and that was determined previously. So we need to find the y-intercept c1. So rearranging this formula and substituting into this formula the point p, c ln p, we get c1 is equal to y minus mx, which is equal to c ln p minus c over p multiplied by p. The p's cancel, and we get c ln p minus c. So therefore, the equation of the tangent is y equals c over p multiplied by x minus c plus c ln p as required. Part B. Find the value of c such that the tangent from part A has a gradient of 1 and passes through the origin. The gradient of the tangent is equal to 1, but the gradient of the tangent from part A is equal to c over p. Hence, c over p equals 1, and multiplying both sides by p, we get c equals p, and we'll call that equation number 1. Now the tangent also passes through the origin, which means the y-intercept is equal to 0. Hence, negative c plus c ln p equals 0. Factorising out c, we get c outside of ln p minus 1 equals 0, and we'll call that equation number 2. Now one solution is c equals 0, but we're given that c is greater than 0, hence c equals 0 is not a valid solution. So solving equation number 2 for p, so solving for this bracket equal to 0, ln p minus 1 equals 0. Adding 1 to both sides, we get ln p equals 1. And raising both sides to base e, we get p equals e. But c equals p from equation number 1. Hence, c must equal e.